Now, you've probably heard people talking recently about rare earth elements, but you might be wondering to yourself, well, what are they? How much of a big deal are they? And should we be worried about them? Well, over the course of the next few minutes, we're going to go through that. We'll start with that question of what are they and, do we actually kind of encounter them? Do you encounter them in your everyday life? The short answer, spoiler, yes. This is the periodic table. You might well recognise it. Where are the rare earth elements? Well, look. It's this kind of area here, so look at that. There they all are, all lined up. Kind of obscure, no one's talking all that much about scandium or yttrium or neodymium, or at least until they were not talking about it much until a few years ago. But this is all really important stuff. And the reason that rare earths matter is not so much because of what they do on their own, it's because of what they do when combined with other materials. So you add them to an alloy and it makes things stronger, it makes it more heat resistant, it makes magnets more powerful. Let me just kind of give you an example of that. I mean, so three tangible places where you're going to see quite a lot of rare earths. Fighter jets, this is particularly the kind of defence side of it. Fighter jets, you're talking about kind of 418 kilograms in an F-35 fighter jet. Type 51 destroyer, 2.6 tons of rare earths in them. Something like a Virginia-class submarine, 4.6 tons of rare earths in there. Now, all of that seems kind of, obviously important, but quite abstract. But there's another place where we all see it in our everyday lives, and that is magnets. So neodymium, when it's added to boron and iron, is basically the best magnet in the world. I'll show you a kind of reason for that in a moment. But you might be wondering, so where is it in your life? Well, if you have something like this, so some earbuds, you've got neodymium. You're dependent on neodymium because you need really powerful magnets to create speakers that are so tiny, tiny as the ones in here. And also, by the way, when I take this, here are the little things, you wouldn't have that without rare earths. When you close that, you get that satisfying snap. That is also neodymium iron boron magnets. So rare earths may seem abstract, but actually it's in all of our lives. And it's elsewhere as well, basically pretty much any electronic device these days. And, in your car. So in your car, for instance, think about sitting in your car, the seat controls. So being able to lift that seat, to move that seat forward and backwards if it's electronic, well, that is it's a motor. It's a little rare earth motor. Being able to raise electric windows and close them, again, that's rare earth magnets going in there, making that function. And airbags, there are even rare earths in airbags as well. In other words, if you can't get rare earths, then you're in trouble. And it's not just inside cars as well. I mean, think about like a car factory. The motors that go into robots, that's rare earths as well. You need those really powerful magnets to make them work. And it's not just that as well, as within EVs, okay? So this is an EV motor. You can see the copper there. Those are the kind of copper windings. But inside most EV motors, you have a lot of magnets as well. And those magnets are rare earth magnets. So it's all invisible, but it's really important. And when I talk about those magnets, just to give you a sense of why this is kind of important, what this is showing you, so the higher these bars are, the more powerful, the more magnetic power you're getting from different types of magnets. And you've got a range of different kind of elements and compounds and recipes for magnets there. These are conventional magnets. Now look at rare earth magnets. Just look at how much more powerful they are than the other type. And that's the point. Magnets are incredibly important for any kind of motion, for any speakers, for microphones, for anything else. And we need quite a lot of them. But actually, the scale of what we're talking about is not enormous. You only need quite a small amount of rare earths to make something function really well. And another good example of that is, consider a jet engine. So the blades in a jet engine, they need to function at a temperature that is higher than the metal's melting point, if you can get that into your head. And in order to do that, they need what's known as yttrium-stabilized zirconia film on the outside. And that enables them not to melt. So no rare earths, and yttrium is a rare earth, no rare earths, and you just don't have jet engines, at least modern jet engines. So this is incredibly essential. It's part of the bedrock of how we make civilization work these days. And if you're looking at just what the functions of these rare earths are, so we talked about jet engines a moment ago, that would come in the metallurgy section of things. There's glass polishing, ceramics, catalysts as well, so it goes into catalytic converters. But magnets is by far and away, this is just looking at the volume of rare earths coming out of the ground. Magnets is by far and away the biggest. And actually, when you look at the value, so the amount that people are spending on rare earths across the planet, the majority of that is magnets. So it's magnets that are going into motors for the most place, as well as things like speakers and AirPods and so on. And here's where the political side of things comes in. Because when you're looking at where these rare earths are coming out of the ground, the vast majority come out of the ground in China. 69% of the total of the volume mined out of the ground, the oxides, comes from China. And actually that's 69%, but then when you consider the processing, so the post-processing stuff, because most of the rare earths are then turned into products in China, actually 91% of global supplies is Chinese. And that's not just the case, by the way, for rare earths. Look at things like copper, look at lithium, manganese, graphite, cobalt. China is really dominant in all of this. They have decided years ago that they wanted to be dominant in these supply chains, and not just the supply chains, but also making the stuff afterwards. So graphite's there. They also want to be the dominant player when it comes to making the anodes that go into batteries. That's why they're in graphite. Cobalt for batteries as well, manganese too, lithium, copper as well. So that is, it's part of this bigger story about Chinese dominance. But here's where there are a few kind of myths that are worth busting. The first of them is that despite the name, rare earths aren't actually that rare. So there's quite a lot of these elements in bits of the ground. Actually, if you pull a chunk of rock, of earth out of the ground, you will find some rare earth elements in there, albeit in small quantities. But even when you look at decent ores, well, China, yes, has a lot, 44 million tons. But there's a lot of it also in Brazil, and they're not really mining much of it at the moment in Brazil. There's a lot in India. There's a lot in Australia as well, 6 million tons in Australia. Now, most of those countries aren't doing all that much in the way of mining. Most of it's happening in China. Why is that? Well, let's just kind of zoom in and focus on the biggest of all the mines in China. So that's Bayan Obo. It's just in kind of Inner Mongolia there in China. And have a look at this mine, okay? We're going to kind of zoom out or zoom in there and have a look at how much this mine has expanded in recent years. And you're going to notice other things as well. So this is the primary mining site. This is back in 2001. And look at what happened in the intervening years, okay? So you can see 2006, you've got these excavations happening over there to the west. And now keep your eye on this area here, and we'll zoom on. We'll kind of fast forward to the present day. Look at that. So this has been an enormous expansion, and you have a whole new mining area over there. This place is pumping out basically most of the world's rare earths in China. And the other thing you'll probably have noticed looking at it is, look at all of these tailing dams where the waste is being disposed of. Producing rare earths is a really dirty process. It is really dirty. It's really hard to do, basically, because you're having to do about 100 different processes to go from the ore to that final metal that you're turning into magnets. And to give you a sense of that, okay, so this is showing you the amount of carbon emissions from various different metal processing. And you're probably familiar with the fact that making steel is really carbon intensive. Think of all those blast furnaces. Well, that's steel there. It's actually quite small in comparison with other things like copper, nickel and aluminium, at least per weight, per amount of kilogram that you're producing. But now compare all of that to neodymium, which is that kind of key rare earth in all of those magnets. And look at that. Boy, I mean, there is more carbon emissions that are coming per kilogram of rare earths than any other metal in the world. It is really dirty to produce. And one of the upshots of that is everyone else out there with all of their carbon targets has said, well, we just don't want to do this in our countries. So now it is mostly happening in China, and it's happening at scale, as you saw a moment ago, and it's happening at such a scale that China is able to produce these things at a far lower cost than almost anyone else in the world. Well, actually, by far and away, anyone else in the world. This is just showing you a couple of examples. Dysprosium and terbium, two rare earths, rare earth elements. Look at how much Chinese prices are, and now let's compare that with European prices, because there are some producers outside of China, but just look at how much more expensive it is to get European rare earths versus the Chinese stuff. And that's the issue. Stuff like those earbuds are cheap right now because you can get cheap Chinese rare earths, but it's produced with all these carbon emissions at the same time. But people aren't thinking about all this. They are thinking about it a bit more now, though, because China has basically said, we are going to impose restrictions on the rare earths coming out of China. You're going to have to sign up to get licenses. And as a result, Donald Trump has said, well, no, I'm not happy with that. I'm going to raise tariffs on you again. And so this is where the latest kind of state of play, this ever-moving map of tariffs that the US is imposing on other countries around the world. You'll recall not that long ago, it said there were going to be secondary tariffs on India for all of the refining it's doing of Russian gas, Russian oil rather. Now, Donald Trump has said there's going to be an extra 100% tariff on China. We'll have to see whether that eventually happens. But this trade war we've been talking about a lot recently seems like it might be back on again. But finally, I just want to kind of raise that question. So China is doing that with rare earths. It's limiting this critical ingredient that no one else is producing. And that raises a question, is there anything similar that the US could do? And here's something interesting, okay? So we'll go back to that map. Okay, so there's China, that's where the rare earths are. Swing across to the US, and there's somewhere called Spruce Pine. It's another mining site, it's in North Carolina. They don't produce rare earths here, but they produce something perhaps even more special. In there, they are mining what's known as ultra-high purity quartz. And this is a type of, basically sand, really pure sand, that you need to make the wafers that go into silicon chips. If you don't have this place, you don't have silicon chips or solar panels. So perhaps one thing, who knows, that the US may end up thinking about is whether it can do the same thing that China's doing with its mine on the other side of the world with this critical ingredient. But who knows? What we do know is that we're on a roller coaster and there's going to be more of this stuff in the coming months.